Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving the following exercises. So the first exercise is on Rolle's theorem and the second one is on the mean value theorem. So let's start with the first one. So the first one states that verify that this function satisfies the hypothesis of Rolle's theorem on the interval 0 and 4 and find all numbers x0 in 0 and 4 such that f prime x0 is equal to 0. So in this one we have to use Rolle's theorem to solve this. And Rolle's theorem states that if a function f of x is continuous on a closed interval, that is on interval like this, with here x1 and x2, differentiable, and the function is also differentiable on an open interval on this same kind of interval x1, x2, and fx1 is equal to fx2, then there exists at least one number x0 in x1, x2, which is in this interval, such that f prime x0 is equal to 0. So that's Rolle's theorem. So we have to verify that this function satisfies the hypothesis of Rolle's theorem. So now, since this function is a polynomial, that means it is continuous and differentiable on every interval. So all polynomials are continuous and differentiable on every interval. So that means this function, we can say that since f of x is a polynomial, it is continuous and differentiable on every interval. That means on this interval it is continuous and differentiable on that interval. So therefore fx is continuous on 0 and 4, which is our interval, and differentiable on 0 and 4. And according to Rolle's theorem, fx1 is equal to fx2, and our x1 here is 0, our x2 here is 4. So f0, which is fx1, will be equal to f4, which is fx2. If we substitute 0 in this function, it should give us the same value as when we substitute 4. So let's do that. 3, this is 0 square minus 12, 0 plus 11 is 11. The answer is 11. Now if we substitute 4, it should also give us 11. You see 11. Then now we have to find the derivative of the function. So it will be f prime x is equals to what? Derivative of this becomes what? 6x, then minus 12. Then now, according to Rolle's theorem, f prime x0 must be equated to 0. So we'll put here as x0. So this becomes f prime. So now instead of x, we're going to put x0. So this is equal to 6 x0 minus 12. And then this is equal to 0. So now this becomes 6x0 minus 12 is equal to 0. 6x naught is equals to 12. Then x naught is equals to 12 over 6, which is what? 2. So x naught is equals to 2. That means we can substitute 2 here. This means that f prime 2 is equals to 0. And according to Rolle's theorem, x naught will be greater than x1, less than x2. So our x naught is what is 2, greater than 0, which is x1, and less than 4, which is x2, from the interval given. So hence we can say that this has satisfied the hypothesis of Rolle's theorem because it has satisfied all the conditions given in Rolle's theorem. Hence we can say that f of x, which is the function, satisfies the hypothesis of Rolle's theorem on the interval 0 and 4. So the first one satisfies the hypothesis of Rolle's theorem. Now let's move to the second one. And this one is based on mean value theory. So it states that show that the curve 5x squared minus 3x plus 1 satisfies the hypothesis of mean value theorem on the interval 1, 3 and find all numbers x naught in 1, 3 that satisfies the theorem. So mean value theorem states that if a function f of x is continuous on a closed interval x1, x2 and differentiable on a closed interval x1, x2, then there exists at least one number x0 in x1, x2 such that fx2 minus fx1 is equal to f prime x0 open bracket x2 minus x1 close bracket. So that's the mean value theorem. So we're going to follow that theorem to solve this. So now this function is a polynomial. That means it is continuous and differentiable on every interval, including this one. So we can say that fx is continuous and differentiable on 1, 3 because it is a polynomial. So therefore there exists a number x0 in that interval 1, 3 such that x2 is what is 3 minus x1 is 1 is equals to what? F prime x0, then x2 minus x1 is what? That's 3 minus 1. So this becomes what? This is 2. So this is 2 f prime x0 So now we have to find f3 and f1 by substituting them into the equation. The equation is 5x squared minus 3x plus 1. So 3 squared minus 3 times 5 minus 3 times 3 plus 1, because our x is 3. So it will be 5 3 square minus 3 times 3 plus 1, which is 37. So we can write 37 here. Minus, then we put 1. This is 3. So 37 minus 3 is what? Is 34. So this is equal to this 2f prime x naught. So now we can divide both sides by 2. This becomes what? This becomes 34 divided by 2, which is 17. So we can say that f prime x naught is equal to 17. So now we have to differentiate the original function and express the x in terms of x naught and then substitute it into this equation. So the original function is what? This will become 10x minus 3. 10x minus 3. So this becomes what? 10x naught instead of x minus 3 is equal to 17. So we can take this to the other side. It becomes 10x naught is equal to 20. X naught is equal to 20 over 10, which is what? 2. So x naught here also is 2. And then we can express the interval. It will be x naught greater than x1 less than x2. So x naught is what? Is 2 greater than x1, which is what? According to the interval is 1. Then less than x2, which is what? 3. So this is the interval. Hence, we can conclude that fx satisfies the hypothesis of mean value theorem on 1, 3. That's the interval 1, 3. So we have successfully solved the two exercises. The first one on Rolle's theorem and the second one on the mean value theorem. And both of them satisfies their respective theorems. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel and hit the notification bell to get notified as soon as I drop a new video. Thanks.